Today we are finally going to get to the quadratic formula. When we look at a quadratic equation or function and we cannot factor it, or if we don't want to use completing the square, our last resort is going to be to use the quadratic formula. At first the formula will look very intimidating, but once we practice it and you just see its order of operations, you may end up choosing just going directly to the quadratic formula because you will know that it works every single time, even when something cannot be factored. So let's go ahead and get started. 11.4, your objective should be saying, I will be able to solve all quadratic equations using the quadratic formula. Once you have that objective down, go ahead and move on. By now you've started to get the idea that when we look at parabolas on a graph, they can either have no solutions, one solution, or two solutions. So yes, in your notes, I would like you to see that you are drawing all three examples. If the parabola has no solutions, it does not touch or cut through the x-axis. Well, you will notice the first parabola goes just above it and does not touch or go through the x-axis. The second example, you will see that it sits right on the x-axis, which means it has the vertex right on the x-axis. That is one solution, 1, 0, one x-intercept. We can also have two solutions, which is what we tend to see most often, is it will have two. It will go through the x-axis once and come back up and go through a second time. So when I'm walking around to check off your notes, I would like to make sure that you have all three examples so we visually understand what we are doing. Now the discriminant, the b squared minus 4ac, that is called the discriminant. That actually tells us ahead of time how many solutions our quadratic formula or function will have. If the discriminant is a positive number, there will be two solutions. If the number is equal to 0, there is only one solution. A negative number will have no solutions. Here's why. The discriminant, the b squared minus 4ac, which you'll see in just a moment in the quadratic formula, it occurs underneath a radical. If we have a positive number under the radical, let's say 25, there are two numbers that can multiply together times itself to equal 25. It could be a positive 5, it could be a negative 5. Both of them, when squared, would equal positive 25. That's two solutions. If the discriminant is a 0, that means there's a 0 under the radical, there is only one way to get 0, that is 0 times 0. It only has one solution. The last one, a negative number under the radical. There is no set of numbers that can multiply together to ever equal a negative number. Now remember, a negative times a negative is a positive. So there's actually no solution. There is no number times itself that will ever equal a negative number to take the square root of. So that's kind of where those rules come from. They will make sense as soon as we continue practicing them. So make sure in your notes that you have written this down. If the discriminant is positive, two solutions. If the discriminant is equal to 0, only one. If it's a negative number under the radical, then that means there are no solutions. Let's take a moment and look at one. We're going to use this discriminant, b squared minus 4ac. Well, the first thing we have to do is remember what is a, what is b, what is c. Well, in this example, a is 1, b is 6, and c is 9. So we're going to look at our b squared minus 4ac. So for b, I'm subbing in the 6. So 6 squared minus 4 times a times c. So all I have done is I have subbed in the b, the a, and the c. Now we're going to use our order of operations. 6 squared is 36. 4 times 1 is 4, times 9 is 36. 36 minus 36 is 0. The discriminant is 0. So visualize in your head, if a 0 is under a radical, there is only one solution. The answer would simply be 0. So now let's practice that again. Look at the next example you're going to write down. A is 1, B is also 1, and C is negative 56. Don't forget to take the negative that's in front of the 56. So we're going to write B squared minus 4 times A times C. So we're going to have 1 squared is 1, and then we've got 4 times 1 is 4, and then 4 times 56 is 224. But a negative times a negative would be a positive. So 1 plus 224 is 225. So the discriminant is 225. If we picture that number sitting underneath a radical, there are two numbers that multiply together to equal 225. It's a positive 15 and a negative 15. So because this is a positive number, that means there are two solutions. Let's go ahead and look at our last one. A is 1, B is 3, and C is 8. Go ahead and sub that in. B squared would be 3 squared minus 4 times A, which is 1, times C, which is 8. 3 squared is 9, minus 4 times 1 is 4, times 8 is 32. 9 minus 32 is 23, but it is negative. So visualize a negative number under a radical. There is no solution. There is no way to solve that, so there is no solution. So take a moment. Using the discriminant will help you know ahead of time how many answers you should get when you are done using the quadratic formula. This is helpful to check if your answer makes sense and seems reasonable. So let's look at that. What I was just hinting right here is that the discriminant b squared minus 4ac occurs underneath the radical when we look at the quadratic formula. Now notice that's underneath the radical. I'm hoping this stuff outside the radical looks familiar to you. Negative b over 2a. That was how we found the vertex back in Unit 10. So that helps us find the vertex. But very importantly, what we're using this unit is the b squared minus 4ac is your discriminant. And that will tell you how many solutions the quadratic formula should have. So now we're going to take a moment and we're going to look at the quadratic formula itself. It says x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I would love for you to hear the quadratic formula. All right, normally in class I have my students sing the song together, but I thought I would play it for you in the video. The idea is the quadratic formula says that x, remember we're finding roots or x-intercepts, is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Now remember, the a, the b, and the c are just like they have been before. So for example, I have this one written here, 2x squared plus 3x plus 4. A is 2, b is 3, c is 4. So the very first thing we need to do is write the quadratic equation in standard form. If it is not already in standard form, that needs to be the first thing that we do. My example in red is in standard form. It is the x squared term plus the x term plus the constant. Once we have it in the right order, we identify what the a is, the b, and the c. Once we know that, we plug those numbers, the 2, the 3, and the 4, into the quadratic formula. Now this is key, essential, super important. We simplify inside of the radical first. According to order of operations, we will go underneath the radical. The square root and square undo each other, they're opposites. So the square root falls under the same category of exponents. Once we simplify inside the radical first, then we will follow the order of operations correctly to simplify. So that's really it. Put it in standard form, identify your A, B, and C, plug them into the formula, simplify under the radical first, then we use our order of operations. Let's take a moment, look at the first example. Now, first of all, if it can be factored, meaning if there are two numbers that multiply together to equal A times C, that add to B, then we should go ahead and factor instead of the huge formula. So is there a pair of numbers that multiplies to -8 that adds to 2? Well, if I do 4 times 2, that equals 8. And if I make the 2 negative, then that matches up. So this can, in fact, be factored. I need x and a +4, and I need x and a -2. And remember, we set these equal to 0, just like we did in Unit 10. And very quickly, we can find the solutions, the x-intercepts, the roots. The first one occurs at -4. And the second one, when we add 2x to both sides, x is equal to 2. That means the two x-intercepts, the two roots, are located at -4 and +2. We were able to find the solutions quickly and easily without the quadratic formula. So please remind yourself, always do this step of something times something to equal something, and something plus something to equal something. If you can find that pair of numbers, you do not need the quadratic formula. You can go right to your two factors that you will set equal to 0. Now, it won't always be able to be factored. So let's look at this one. Write down this example, 3x squared minus 5x plus 1. If I want to see if there are two numbers that multiply to 3 that will add to -5. Well, the only way to multiply to 3, because it's prime, would be 3 and 1. Well, there's no way to make 3 and 1 equal -5. So this one cannot be factored. So what we're going to do is identify our A, our B, and our C. A is 3, B is -5, and C is 1. So we're going to go into that quadratic formula that says x is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So let's go ahead and sub those in. We will have x is equal to a negative, but we're subbing in b, which is a -5. So be very careful with that negative right there. We'll come back in just a minute. All plus or minus the square root of b squared, so parentheses for my -5, minus 4 times a times c. So -4 times 3 times 1. Anytime we see minus 4ac, that means we're multiplying -4 times a times c. And that's all over 2a, which is 2 times 3. All right, that looks kind of messy and kind of tricky, but we can do this. Watch how quickly we simplify this in the very next line. A negative times a negative, my -5 becomes a +5, plus or minus the square root of -5 squared. Two -5s, -5 times -5 is +25. Now let's do this part. -4 times 3 times 1. -4 times 3 is -12. -12 times 1 is still -12. All over 2 times 3, which is 6. If I were to just quickly and easily simplify this one down, we'll have 5 plus or minus the square root of 25 minus 12, which is 13, all over 6. So now we have two ways. We can write this as 5 plus radical 13 over 6, and we can write it as 5 minus radical 13 over 6. So you will need to find out if the question asks for your answer to be written in radical form, then you leave the radical signs. If the answer asks to be written in decimal form, here's where you need to take your calculators. You will type in the square root of 13, and you will see that it equals 3.6. So we would have 5 plus 3.6 all over 6, and we'd have 5 minus 3.6 all over 6. So if we were to do that in our calculator, 5 plus 3.6, that gives us our 8.6, and then divide that by 6, we will get an answer of 1.43. So our answers would be 1.43. That's this one when I simplify. Now if I look at 5 minus 3.6, that's 1.4. Divide that by 6, and we will get 0.23. So those two x-intercepts come from us simplifying our fractions. 1.43 is an x-intercept, 0.23 is the other x-intercept. Remember, that's why the quadratic formula says x is equal to, because we're finding the x-intercepts. So make sure when you're reading the problem, if it asks for you to leave your answer in radical form, you could stop here. If they ask for your answer to be in decimal form, you need to take the square root in your calculator and have your answer end up in decimal form. Now, this looks messy and it's kind of spread out, but you will see the more we practice that we simplified under the radical first, you will see how much quicker this will go with the next one. So here we go. Here's your next one to write down. 2x squared plus 5x minus 3. First things first, can it be factored? Are there two numbers that multiply to 2 times negative 3 that can also add to 5? If we can, that would be 6 and 1. If we make the 1 negative, that does in fact work. So we have two choices now. We can go the factoring route and factor it, where you can use your square and put your first term first box, last term last box, or we can go to the quadratic formula. I'm going to choose for this one to use the quadratic formula just so we can practice, since that is the point of this lesson. So remember the formula, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's identify our a is 2, our b is 5, and our c is negative 3. So let's go ahead and sub that in. X is equal to negative b, so negative 5, plus or minus the square root of b squared, which would be 5 squared, minus 4 times a, which is 2, times c, which is negative 3. Don't forget, that's all over 2a, 2 times 2. So that's how we start by setting up. I'm going to move to the side this time. Now remember, we said we want to simplify under the radical first. We do what's inside the radical. So under the radical, we had 5 squared. That was our first part. So we're going to do 5 squared is 25. Now remember, these three things all get multiplied together. 4 times 2 is 8. 8 times 3 is 24. And a negative times a negative is a positive. All over 2 times 2, which is 4. Look how simple we made that one. We are almost done with the radical number under the radical being just one number. So let's go ahead and finish that. 25 plus 24 is 49. All over 4. Ooh, I'm hoping when you saw the square root of 49 that you got a little bit excited, because 49 is a perfect square. If I continue my work, x is equal to -5 plus or minus the square root of 49 is 7 all over 4. There's no radical. Because this was a perfect square, when we take the square root of 49, we just have 7. There is no more radical in the problem. So we can simplify. We want -5 plus 7 over 4, and we want -5 minus 7 all over 4. So let's simplify that. -5 plus 7 is 2. 2 over 4 equals 1/2. So one of my x-intercepts is at 1/2. If I simplify -5 minus 7, that is -12. -12 over 4 is -3. So the two x-intercepts occur at 1/2 and -3. So these are not numbers that we would be able to come up readily when factoring because they are not whole numbers. However, the quadratic formula will always work for us. So once you feel comfortable with that problem, we only have one left, and then we'll be done with our notes. Go ahead and write this problem down. 3x squared minus 10x minus 2 equals 2. I am hoping the very first thing you notice is that it is not quite in standard form. It needs to be set equal to 0. So that means this 2 is in the wrong spot. I need it to come over to the other side of the equal sign. Well, the way we move it is it's a positive 2, so we're going to use a -2. So we're going to do minus 2 and put it underneath its like term. So now the equation we have says 3x squared minus 10x minus 4 equals 0. Now we are set equal to 0. Now we are ready to solve. If we're trying to find two numbers that multiply to -12, that add to -10, there is not a pair that will do it. 1 and 12, 2 and 6, 3 and 4. There is no way to do that. So we must go to the quadratic formula. So I'm not going to write the formula down. Let's see how we do subbing in. X is equal to -b plus or minus, don't forget this is A, this is B, and this is C. So -10 plus or minus the square root of b squared minus 4ac all over 2a. So let's simplify that down so it doesn't look quite as intimidating. We'll have -10 plus or minus the square root of. Let's do -10 squared. Two -10s, 10 times 10 is 100. Now remember, we multiply these three numbers together. 4 times 3 is 12. 12 times 4 is 48. And a negative times a negative is a positive. So we have plus 48 all over 6. So let's continue. We are really close to underneath the radical being down to one number. So we have x is equal to -10 plus or minus the square root of 148 all over 6. So let's go ahead. 148 is not a perfect square. So in our calculators, we're going to do the square root of 148, and we will find that it equals 12.2. So if I were to continue, we'd have -10 plus or minus 12.2 all over 6. Now once I took the square root of 148, notice there's no more radical in my fraction. So now I'm simply going to break it into its two fractions. I want -10 plus 12.2 all over 6, and I want -10 minus 12.2 all over 6. So if we do -10 plus 12.2, that would be 2.2 divided by 6. So in our calculators, we're going to do 2.2 divided by 6, and we will get an answer of 0.36 where the 6 repeats, so we'll just go with 0.37. That is one of our x-intercepts. Our last one, -10 and -12.2, is negative 22.2 over 6. So we're going to do negative 22.2 divided by 6 in our calculators, and we will get that x equals a negative 3.7. So the x-intercepts for this equation occur at 0.37 and negative 3.7. So if you're starting to feel more comfortable with using the quadratic formula to find the solutions or roots or x-intercepts, then you are done with your notes and you are ready to get started on your assignment in class. If you feel that you would benefit from going back and rewatching any one of these problems, feel free to rewind or replay and make sure that you are comfortable and you can say that you can solve quadratic equations using the quadratic formula.